our speakers. First up, we have a presentation from Sarah Wilson, GIS Analyst with the SEAI Energy Statistics Team, who will be presenting GIS as a resource within SEAI, Sustainable Energy Authority of Ireland. Our second topic will be presented by my colleague, Anastasiia Khil, EO Analyst with Mallon, who will be presenting Scalable EO, Data-Driven Environmental Decisions. They'll each be introducing themselves, so I'll hand it over to them now, and I hope you enjoy the session.
Thanks, Sandra. If you just let me know if that's working okay.
Yep, we can see the screen. Thank you.
Perfect. Thanks very much. Hi everyone. Thanks for having me here today to speak. My name's Sarah Wilson, and I'm a GIS Analyst at the Sustainable Energy Authority of Ireland, specifically part of the Energy Statistics Team within the Data and Insights Department. So I've been with SEAI nearly a year and a half, and I've been working in GIS around 7 years. So today I'll be talking about how SEAI is using GIS as a tool to support and inform a sustainable energy transition and to help hit those sustainable goals. But before I start talking about GIS within SEAI, I wanted to give a short intro into my background and how I got into GIS. So growing up, I was always interested in science in school and just generally how things work. I went to a mixed school and I was one of 3 girls in a classroom full of boys. So science was never really promoted for me. And at the time, I had no idea if it was even a sensible career choice or not. I was also very outdoorsy, and through school, I was able to be part of the Duke of Edinburgh, which is kind of like the Scouts. And that's where I first learned how to read a map. So I love being active and challenging myself, and I have a lot of hobbies such as scuba diving. And for any geography nerds on the call, that's me diving between the North American and Eurasian tectonic plates, which was a very cool experience. So when I went to university, I wanted to keep all those things in mind. So I done my degree in marine science at Ulster University. It was very hands-on. There was a lot of lab work, field trips, boat trips in Cork, and even a study abroad year to Australia. That's where I got my diploma in international studies. So the course covered a wide range of topics from statistics to marine biology to cartography and even environmental law. And when I started the course, I had no idea what I wanted to specialize in. I had this idea of scuba diving and working in exotic places and studying fish. And it took me a while to realize like what jobs were possible with my degree and also what was available in Ireland as well. And it was only through talking with friends and lecturers at the time that they suggested GIS. So that's what I'd done. I was looking at applying for GIS jobs. So my first GIS job was through Esri Ireland, and I was contracted into Irish Water. I was working with the PRAI on asset transfers, digitizing boundaries, and that gave me the experience and confidence then to apply for other GIS roles. And that led me to An Post, where I was mapping postal routes, analysing population statistics, and even working with geodirectory buildings data. And I was there for about 4 years. I then moved to Arup, which was a very different experience as I hadn't worked in the engineering sector before. I was working on projects such as the expansion of the Dart coastal route and even the very topical bus connects. And finally leading me to my current position with SEAI that I'll talk further on in a minute. I also recently done a CPD in GIS with TU Dublin, and which has really helped bridge my gap on my GIS knowledge, learning more about WebGIS and raster data as well. So I've been around the block a bit, but I feel like it's given me the experience to be where I am today. So that was a quick intro to me. I want to introduce you to SEAI for those who are unfamiliar. So who or what is SEAI? Well, it's Ireland's National Sustainable Energy Authority. They work with householders, businesses, communities, and governments to create a cleaner energy future. You've maybe heard or seen a few TV and radio ads about SEAI, and we're mostly known for grants. But we also look at BER, which is the Building Energy Rating, provide energy upgrade support, which is grants and funding, work to support development of clean energy technologies, and that's just a few points of what goes on. So there's many other functions such as marketing, sustainable communities, research funding, and energy statistics, which is where I fall into. So the Energy Statistics Team would predominantly look at Ireland's energy stats as the national, such as the National Energy Balance, which is actually out on the 17th of December for anyone that wants to do some light reading over Christmas. We're providing comprehensive national and sectoral energy statistics, which is vital for international reporting obligations, guiding policies, and informing investment decisions. So where does GIS fit into all of this? So I'll start by showing how we've been using GIS within SEAI, and then there'll be a focus on one of our recent projects involving sustainable energy communities. I'll also touch on how GIS can provide insights to help Ireland transition into a sustainable future. So, for example, if you were to look at houses that are in close proximity to public transport or bus stops, you would be less likely to need an electric vehicle. So where you live can be important into how you can be sustainable. Or if you were to map all of the wind farms in the country on a page, you might notice that most of our wind energy comes from the south and the west of the country. These details you may have missed by only looking at a table. So having GIS and being able to view this data through a different lens is giving us evidence-based insights. So I'm sure many of us in the GIS world are familiar with these geographic boundaries. I'm going to use them to help explain some of the projects and the data that SEAI has. So in Ireland, there's conversations going on at these different levels, and using GIS is a means for synchronizing those conversations. So these conversations help inform discussion and debate on policies and planning by feeding that evidence-based data-led conversation. So within SEAI, we can provide data and insights across these 4 levels of granularity, starting at a national level to regional or local authority, to communities, and even down to individual buildings as well. So I'm going to talk you through some examples of how GIS has helped inform planning and decision making, and I'll start with the national level. So there are multiple national targets to be met in Ireland before 2030 under the Climate Action Plan. Today, I'm going to talk about solar. So these specific targets are to have a certain level of solar capacity installed before then. So the question is, once these policies are in place, we can aid in answering questions such as, well, where did they get built or have they been installed? So the first thing that you might look at is, where's the current solar farms? So this map shows not only the location of the solar farms, but also their relative size and how much electricity they produce. So on the map, the size of the circle scales with the MEC of the site, which is the maximum export capacity. So no surprise that the connected farms are in the east. So next, you might want to consider where's the contracted farms. So these are locations of planned solar farms, but not yet connected to the grid. So in this image, we can see there's actually quite a lot planned for development. Again, the size of the dot corresponds to the MEC of each site. So SEAI has all this information that we share with the public as a tool to help aid these development decisions. So next we might consider where's the most sunlight. You can see the nice sunny southeast there in yellow. So this was a reason for building our solar atlas, which is a map showing where in the country receives the most sunlight on average. So it's a very useful resource for solar farm developers in particular in planning potential sites, and we're making all of this information public. But it's not just that simple, unfortunately. There's many other considerations. So not just level of sunlight considered during planning. We also have these restricted areas for site development on the atlas. These are called solar safeguarding zones, which are basically just zones around airports because the glare of the solar farms are a danger to pilots. We can also consider special areas of protection and conservation, as these are always considered during any sort of planning and development. There's also the ability to connect these places to the grid. So by having GIS as a tool, it's given us the ability to bring all of these layers together to build a bigger picture and intuitively find those areas for site selection. So it's easy to use and freely accessible resource the SEAI has provided to help aid in that decision-making process. And solar is just one of our mapping resources in SEAI. We also have bioenergy, geothermal, heat demand, district heating potential as well, and probably our most popular one, which is our wind atlas. So now you've seen examples of what national data SEAI provides. I'm going to switch our focus to a regional level and how we've disaggregated energy data down to a local authority level. So the SEAI Statistics Team speak to national figures through the energy balance, but to look at data on a national level, there's very little spatial breakdown. So in order to add spatial value, this data needs to be broken down into smaller zones or boundaries, which is where GIS can help. So in recent years, there's been more responsibility for climate action placed on the local authorities. And the local authorities are now mandated to draw up their own local climate action plans, which they outline mitigation and adaptation measures they intend to take against climate change in the next 5 years. But as a result of this, we've experienced a high volume of requests for data at a local authority level. So in response to that, we created this local authority climate action plan dashboard that we've maintained now for the last 2 to 3 years. So this is the dashboard homepage. It's intended to be a one-stop shop of sorts for local authority staff or contractors that are looking for energy-related data specific to their regions. So there's information on wind capacity, home energy upgrades, BERs, in an intuitively visual way, but you can also download the data into a spreadsheet for their own analysis. So the local authorities are required to prepare these climate action plans once every 5 years. So the data on this dashboard is actually updated every quarter, so it's always the most up-to-date information that you can get. So, for example, the dashboard provides information on the so this is for Galway County Council. So the number of wind farms you've connected and planned, and also the maximum export capacity as well. So another example showing home energy upgrades, this time for Laois County Council. So we can see the breakdown of the SEAI funding that's been awarded to homeowners in that local authority through SEAI's various grant schemes. Now that's just 2 of the 7 tabs on the dashboard at the minute, and the local authorities can use this information to get information on domestic renewables like heat pumps, solar PV, level of wind or solar generation in their area. So by having this dashboard, it's allowed for a high degree of parity of practice, and that we're sharing the exact same quality of data with all the local authorities at the same time, which is something that's very difficult to achieve when responding to ad hoc email queries. And within the last year, we've wanted to take things a step further and provide even more data to the public. So we can zoom in further now to the 19,000 small area divisions from the CSO that they use to provide granular data. But we also want to make sure that we're still providing individual confidentiality. So I'm now going to show you an example of how GIS can provide insight at the community level. And when I talk about community level, I'm referring to data at the level of the census small areas. So that's the smallest official geographic breakdown of the country. And I'm going to talk about a project that's all about providing data at the community level. So this leads me to the sustainable energy communities. So an SEC, or Sustainable Energy Community, is an SEAI network, sorry for all the acronyms, that work together to develop a sustainable energy system for the benefit of the community. They're kind of in comparison to the tidy towns, which is probably more commonly known. They aim to be as energy efficient as possible, use renewable energy where feasible, and try to consider smart energy solutions for their community. They can be as small as a street or as large as a county. And there's currently over 900 SECs registered with SEAI around the country, which is quite a lot. And it's important to note that these communities, they plan at a regional level, but action at a community level. So that's why it's important to show spatial data at a community level. So this dashboard was built to help in the planning stage, which is the second stage. This involves creating an energy master plan. So a big part of this process is collecting data on the residential sector. And I think we all know how tedious data processing and collection can be. These communities know best on what they need and what challenges they are facing. So to help aid in this energy master plan process, I was able to lead on a project that helped to build this dashboard and help address those challenges. So this is a screenshot of the dashboard homepage. What we wanted to achieve was combining statistical and spatial information side by side in an intuitively visual way by exploring detailed data on dwellings that have had their BER assessment carried out. So how would this dashboard be used? Well, maybe I'm a contractor in charge of an SEC and I need to know where heat pumps are in my area or what type of walls houses in my community have. And I want to inform the community from Balbriggan undertaking an EMP. And I want to find real-time energy related information on the current residential building stock in that area. So I filtered to my SEC of Balbriggan. And this then shows the outline of my SEC, where it is, along with filtering out all the rest of the energy-related tabs, graphs, and information in the rest of the dashboard. So the dashboard includes various energy-related topics such as BER, dwelling type, fuel type, and a couple of others. So as a contractor establishing an energy baseline, I might need information on the building energy ratings first. So as you can see, it's already pre-filtered and zoomed into my community area. All the boundaries are small areas that are associated with that SEC of Balbriggan. They each have their own median BER breakdowns. There's also an associated chart showing the breakdown of median BER values for the SEC as a whole. So for example, 18% of the BERs is a value of C1 in that area. So the chart sums the ratings for the SEC and then the map shows where exactly the breakdown of BER is. So for example, the town centre here is predominantly yellow. So that means this area has buildings with predominantly lower BER values. So this is going to help visualize areas of interest and help in answering questions on where you may want to promote energy upgrade grants where there's lower BER values. So what else could I do as a contractor to get more information? Well, maybe my community needs certain types of energy upgrades. You could look at cavity walls as an example. These are a cheap insulation solution. So that would lead me to looking at my wall types. So through our home energy grants program, you'd be able to apply for certain types of insulation grants in SEAI. One of the first questions you're asked is, well, what type of walls do you have? So this dashboard has the ability to show an indication of where the dominant wall types are within this area, and this can help in narrowing down areas of your community to focus on. Again, heat loss indicator gives you an indication of the average heat loss indicator values of homes in each small area. It tells you how quickly heat escapes from a building. So you can see straight away on the map areas on average with very poor home heat loss in red. So it's a good first step in assessing your own individual homes, as these areas could potentially avail of an SEAI grant scheme. And it's not just older homes. The newer built houses have a good heat loss indicator, are less likely to need upgrades. However, that can be a good indication on whether you could avail of getting a heat pump installed. So you need a certain heat loss indicator value in order for a heat pump to operate efficiently and in your home and qualify for a grant as well. So having these maps is good for creating these EMPs, but it also benefits homeowners by saving money on their energy bills. And in the long run, it's good for Ireland as it will just energy demand overall. There's also further potential to combine these areas with population statistics, such as areas with elderly populations or areas of poor health to focus on and make priority. You could use this by using the CSO census data. And saving the best widgets last, you have the ability to download all of that information into a spreadsheet. So the communities or contractors can download this data for their own further analysis. There's information on individual BR ratings for each dwelling, and also BR data aggregate up to a small area level as well. And there's extra information on homes that are not actually featured in the dashboard itself. And one dimension of interest within these communities is the ability to monitor the uptake of the SEAI grant funding in their area. So we have a separate page for this. You can see information on grants here in the charts. So the data is aggregated to a community level and it's sourced through our grant scheme databases. You can see from the graphs here for Balbriggan that the numbers are going up, which is exactly what you would be hoping and wanting to see. So I spoke about the current SECs, but the dashboard also has the ability to design and scope new SECs. So there's a map with all of the small areas in the country, so it's 19,000 boundaries. So that's a lot of information. The page provides the ability to select multiple small areas of your choosing and then export this data related to those areas into a table of data. So that was a very quick run through of the SEC dashboard. There's also a lot more functionality under the hood as well, such as the ability to export maps for reports. So finally, just to note that SEI is using residential building data as well as an internal resource, for example, by looking at individual grant applications in the SEI database. So I hope I've shown here today how we can connect data between all these different levels, from the 2 million buildings to the small areas, to the local authorities, and then up to a national level as well. And also how GIS can be used as a tool to support in a sustainable energy transition. So we have many other resources and GIS tools that people can use, and I'll just leave you with some mapping links for anyone that's interested. It's some of our most trafficked sites. So I'm happy to answer any questions now, or if you do want to contact our team, I've put our email in there as well. And thank you for listening.
Thank you very much, Sarah. That was very, very interesting. We have a question in here from Sita. She says, thank you very much for a very informative presentation. I see a lot of resources publicly shared by SEAI, such as wind and solar. I was curious if all that information is the output of research done by the SEAI team internally, or are they gathered from other partners or sources?
Yeah, the likes of the wind and the solar, it really depends on the data. So sometimes we get information from the likes of ESB, or what's actually connected to the grid. But we do have a research department in SEI, but we also work with the likes of the EPA, the CSO. There's a lot of collaboration going on as well within SEI. So yeah, it really just depend on the actual topic as to. But yeah, we do internal and collaborate as well. Just depends on the data.
Great, thank you. I have a question myself. Do you collect usage stats on the dashboards, and what sort of findings, if so, what sort of findings?
No, we don't. We've had a lot of feedback from the SECs and from the SEC team within SEI that it's been a great resource and it has been used. But we don't have actual numbers on it. But yeah, we've had a lot of feedback and it's been a very used tool so far, and we've even made improvements over the year as well. So I know it's being used by a lot of SECs, but I don't have the actual stats on how many people are using it.
Grand. And just actually another final question for me. You can download the information in Excel format, not shape files, just Excel and maps, is it?
Just Excel at the minute, yeah. But it's probably something that we could look into adding in the future once we progress.
Brilliant. Thank you very much. If there are no other questions, we might move on to Anastasia's presentation.
Yeah, thanks, Sandra. Thanks, Sarah, for a very interesting presentation. So, final checks. Can you see my screen? Can you hear me well?
I can see your screen and I can hear you, yes.
Yeah, perfect. So, my name is Anastasiia Khil, and I'm Earth Observation Analyst at Mallon Technology. And today I'll tell you about scalable Earth observation, data-driven environmental decisions. So my geospatial journey started at National Aviation University of Ukraine. I earned bachelor's degree in geodesy, cartography, and land management, and later I got a master's degree in geoinformation systems and technology. So you can see that my university years were filled with practical activity, some conferences, hands-on experience. And for example, here you can see me making some last-minute edits before submitting topographic plan, before submitting it to my teacher. So I also was involved in research activities. So you can see some of them. For example, I was working with air pollution in Ukraine, and you also can spot that the eastern part of Ukraine, it has the most polluted region of Ukraine because of mining activity and heavy industry and power plants. And I also was working with mapping of landscape roughness, and you can spot here, for example, Carpathian Mountains and Crimea Mountains as well. But in my final years of university, I deeply interested in data analysis and data science. So I gradually started building some new skills and learning more about data analysis. And it led me to my first job as data scientist at a small company, Artid. And it was very valuable experience. I'm really grateful for it, but I kind of missed EO data, EO analysis, and satellite data. So that's why my next role was at EOS Data Analytics. It's a great company, and one of the most popular kind of project of this company, it's a crop monitoring. I was also working with forest monitoring and mapping of soil organic carbon. And here you can see me watching the launch of SpaceX Falcon 9 carrying the EOSat-1 satellite commissioned by my company at that time, EOS Data Analytics, and built by Dragonfly Aerospace. It was the first commercial agri-focused EOS satellite in the world. So EOS Data Analytics gave me like unique experience. And then I moved to Ireland, and in 2024, I joined Mallon Technology. And Mallon Technology, it's an industry leader in GIS and EO fields. And it's one of the biggest contractor for central government, but it's also a very great company with the kind of it's a people-oriented company with a strong EO team, which I'm proud to be part of. So as you can notice, I really love data and working with data, and in EO we deal with the huge amounts of data and huge variety of data. We have different nature of data, like radar, we have optical data, we have different resolutions, different sizes, different satellites and their characteristics. So it sounds a bit challenging, but it's what really fascinates me. But you always have to remember that data can be tricky. And one of the examples of this can be Ensembles quartet. So you can see 4 samples of data, and all key statistics of this data, they are the same, they are very, very similar. So all this data have similar mean values, variance, similar linear regression line, and similar correlation. But they look so different, and that's why we always need to take time with our data and try to understand our data more to before putting them into some algorithms. We need to know what's going on. And sometimes something as simple as NDVI composite or false color composite, kindly provided by my colleague and today's host, Sandra, they can give us some insights, reveal some hidden features, and tell us what's going on the ground in this case. And so as you can imagine, at Mallon Technology, we deal with a huge amount of data, so-called big data. So, but some of you may remember that years ago, the EO workflows, they were very different. They were dependent on local downloads and heavy desktop GIS, at making just scaling almost impossible. And we also need to remember or take into account that satellite data grow every day, and we have now volumes from gigabytes to petabytes of data. And our local machines, they just simply couldn't keep up with it. But thankfully, great news that we have cloud platforms, such platforms as Google S Engine, Sentinel Hub, CryoGIS, or CDAC. And these platforms, they help us bring our code to the data and not just data to our local machines. At the scale we operate at Mallon Technology, it's a national scale. And for example, for CAP monitoring, it's a national scale. It's a huge amount of data. So in our work, we use CryoGIS, CryoGIS cloud provider. And just to give you some a feeling of the scale, sometimes we have 20, 30 virtual machines running at once, simultaneously for weeks, to handle all our processes and to deliver our result on time. And we have different projects, many different projects, but unfortunately I'm a bit limited in time, so I will just tell you about 2 of them. And one of them, it's a moving event detection. So the aim of this project was to detect a moving event, detect a grass cutting. So you can see how it looks like on Sentinel-2 images. So the first image where we have grass on the field, and the second one, it's where we don't have grass on the field anymore. So for this, we used a combination of NDVI and coherence. So basically, coherence just shows us the difference between 2 images, between 2 radar images. It shows us whether something changed over time. And these 2 events were selected as the best representation of grass-cutting event. Because you can see on the plots, for example, the NDVI, it's a green line, and coherence, it's a blue line. So you can see that after moving event, like after this vertical red line, you can see the kind of a drop in NDVI and raise in coherence. And it's a pattern that something happened on the field and the grass was cut. And as we work with like data of different natures, so it's radar data and it's optical data, we also need to apply like a series of pre-processing steps. And the first pre-processing step is to calculate median value for the whole parcel, for the whole period. So on these graphs, you can see example for how it looks like for one parcel. So it's one parcel, two signals, NDVI and coherence, and the whole period for what we extract the data. Then we resample data to have the same sequence of the same length, and then we add some smoothing. And as a result, you can see on this plot how it looks like. So it's a bit confusing, so don't worry, I will like walk you through this. So you can see two signals, again, green NDVI and coherence pool, and you can spot two events, like that something happened, two moving events on January and on August, in August. This vertical orange line, it's our ground truth data. So it's what's really going on the parcel. And when it's 0, it means that nothing happens. So grass is growing, nothing happens. And you can spot it in the beginning and in this like kind of middle between two events. And where you see 1 or 2 like number, it means that there's some activity. And vertical purple line, it's our prediction. So it's how our model detected moving event. And you can see that our model detected 2 events out of 2. It means that it works great. And next one, next project, it's a temporary subdivision detection. So I'll give you overview. Again, please don't be overwhelmed with the number of images. I'll also walk you through them just in a second. So the goal of this project was to detect temporary subdivision within a parcel for a specific period. And as you may know, like farmers, they don't always keep the boundaries that they submitted to the system. So the boundaries can change time to time. And our goal was to detect whether those boundaries submitted by farmers correspond to what we see on the ground, what we can see through satellite images. So we wanted to compare like farmers' boundaries with the real boundaries of crops or kind of activities that happens on the field. And for this, we used open source AI for boundaries dataset. And we also developed like massive pre-processing pipeline to be consistent with our training data. And here you can see our pipeline and almost all steps from this pipeline. So the first row of this images, like of this pipeline, it's our raw images. It's what we can access through, for example, GIS EO data storage, or what we can access through Sentinel Hub or CDC. So it's raw images for our specific territory. Then you can see like the next row, it's our cloud masking and masking of outliers. So it's outliers detection and then masking of outliers step. So this like kind of like a white blank spaces, it's clouds or outliers. So we mask them. After masking, we need to kind of fill in those gaps, like to have consistent imagery. And we use interpolation for this. So the third row, it's interpolated values. We have, for example, for this one, we have neighboring images, and we can't fill those gaps, like fill those white blanks using interpolation. And the fourth row, after interpolation, we want to resample data and smooth data. We need to resample data to have data gradually represented for each month. So for this, we use resampling to 5-day resampling, and then we use smoothing to smooth data a bit because it still can be a bit noisy after interpolation. And you can see that the kind of resample data because dates have changed. So now we have equal intervals between images. And then the final step is to create median composites for each month. So for example, you can see like 4 images for January here on the fourth row. For example, we have more like 4 more images, and we took those 8 images and created median composite, and it's our result, what you can see kind of January here, what we can see or what we can have for January. Yeah, and basically how our pre-processing pipeline looks like to be consistent with AI for boundaries dataset. And then we took 3D vision transformer and we trained it 2 models. So the first model was trained on RGBN composites, those kind of median composites. And the second model was trained on NDVI. So it's basically the same. We use the same RGBN composites to calculate NDVI composite from them. We trained it to model. We took results from those 2 models and we merged those 2 results into one kind of probability mask. And then we applied several post-processing steps. So the first one, it was the skeletonization to thin like the boundaries of the polygon, but preserve their location and kind of save small polygons. And then we used vectorization to get polygons. And then we used smoothing. And on these images, so you can see the red line, it's what farmers submitted. And the kind of yellow polygons, it's what we received from the model. And you can see that the line, it doesn't represent the real crop, like line between crops. So in this way, we could identify those parcels with the kind of issues, boundary issues. And what I also want to say is that at Mallon Technology, we try to automate as many processes as possible. So we use artificial intelligence to be able to deliver results at a such scale, like at a national scale. But it doesn't mean that we kind of rely on our models and we use only like our models and processes. There is also manual labeling, there is manual checks and quality checks. So it's never just an AI. We try to bring people to all processes to be sure to check our models and processes and to be sure that we can trust them. And next slide. So I want to, having this opportunity, I want to promote our blog a little bit. So we have a blog with many interesting researchers, with like research pieces, with a small one and more serious one. and many of my colleagues have contributed to this blog. And our goal, our mission is to raise awareness in our field and also to distract a bit from day-to-day work. So this small research or more serious, it's what we are passionate about. And here you can see two blogs from me. So the first one, it's a mapping urban heat islands in Dublin and how temperature changed from year to year. And the second one, it's a mapping of urban sprawl and how Dublin grew over 5 years. So yeah, you can ask, you can visit our blog and find something interesting for you as well. And that's all from my side. Feel free to join me on LinkedIn and also follow our company. And thank you for your time and your attention.
Thank you very much. That was a very in-depth overview of your work. Very interesting. I'll just open up the floor to any questions. I just have one quick one myself. Roughly how long does it take to develop a model from, I guess, when you're first given the task to when you can say we're happy with it?
Oh, it depends. It depends on the task, I suppose. So there can be like small research, like proof of concept, and it can be like done very quick. And sometimes it's something so complex as temporary subdivision work where we need to develop also like pipeline for pre-processing and then post-processing and kind of work with a huge amount of data again. So it can take months. So it's really depend on the data and on the project, on the task.
Thank you. I'll see if anyone else has any other questions. And I have one more for myself. Could you tell me a bit about the satellite EOSat-1?
Oh, yeah. So it's a world's first commercial agri-focused satellite. It was commissioned by GIS Data Analytics, and it's optical satellite. It has panchromatic channel, like a band with a resolution of 1.5, and the other bands, they are something near like 3 meters resolution. So it has very good resolution, and it's focused on agriculture tasks. So it has kind of red edge bands, red band, so aerosol as well, and others. And yeah, it was just a great experience. So just not to mislead you, I didn't take part in building that satellite. But our company kind of analyzed the images, and at that period, so at the 3rd January 2023, we were kind of one organism looking at the launch of this rocket carrying our satellite, and it's kind of a big satellite. So at that time, Falcon carried like many satellites, and mostly they were kind of very small. And ours was big, and we even we could notice how it was detached from the rockets, and our like work chat was overflowed with messages and photos and everything. And then we were able to receive like a first images and analyze them and everything, like all the calibration, all processes to get image from the like raw data, all done by US data analytics. So it's also very unique and interesting experience. Yeah, thank you for the question.
Brilliant. I have a question from Dara. Very impressive presentation, thank you. Are there times of the year where cloud providers such as GIS come under strain from all EU users trying to meet deadlines for CAP schemes?
Sorry, could you please repeat maybe?
Yeah. So are there times of the year where cloud providers such as GIS come under strain from lots of different EU users trying to meet their deadlines for CAP?
Maybe I'm not the best person to answer this question, but I've never like noticed that we like have our processes somehow depend on other users.
Mhm.
So we have our virtual machines, we run them, and nobody can access those machines except us. And yeah, I don't think that it somehow influence. It's kind of overloaded or something like that. I don't think so.
Great, thank you. Okay, I don't think there are any other questions. So we will, I'm just going to, we'll finish up here now. And I just want to say thank you, firstly, to our presenters, Sarah and Anastasiia. And also thank you to everyone who attends these webinars. We appreciate you coming along and your engagement and your continued support. And before we sign off, just a quick reminder that the recording of today's webinar will be available on our YouTube channel, so feel free to rewatch it or share it with colleagues who couldn't make it. The Women in Geospatial webinar series is taking a short break, and our next webinar will be held on the first Wednesday in February, so please mark your calendars. Thank you and enjoy your day.